Today we will discuss about the cleavage of polyhydroxy compound using periodate, that is periodic acid. So glycol, glycerol, carbohydrates, derivatives of carbohydrates and such as glycoside, they can be cleaved by HIO4, that is called oxidative cleavage. So in general SUH and SCHOH, that is formic acid and methanol is formed. Cyclic compounds are also formed. So here are more tips for you how this cleavage occurs. So cleavage between CHOH and CHOH occurs, cleavage between CH2OH and CH2O occurs, cleavage between ketohexose. So CH2OH, carbon, this is 1 degree alcohol, carbonyl group, CHOH, CHOH and CH2H. So this is polyhydroxy ketone. So cleavage occurs from here between CH2H and CO, between CO and CHOH, these two CHOH, all CHOH. Okay, so how many moles of HIO4 would be used? 1, 2, 3, 4 and 5. That we'll discuss later on. Okay, so 5 moles of HIO4 are required to cleave this polyhydroxy ketones. So there are few tips, as I told you that cleavage between this CHOH occurs, CH2OH occurs and hexose occurs. Now when 2 or 3 or more than 3 CHOH groups are contiguous, means they are just one after another. The internal one are oxidized to formic acid. See here, this is internal one, CHOH is internal one. So internal one is oxidized to formic acid and the top of CH2H grouping and CH2OH grouping, they are converted into formaldehyde. Clear? So CH2H converted into formaldehyde and this CH2H also converted into formaldehyde and this CHOH oxidized into formic acid. Clear? So this is oxidized into formaldehyde, this is oxidized into formaldehyde and this is oxidized into formic acid. So how many moles of HIO4 would be required here? See here, I have cleaved here 1 and this is 2. Means this much cleaving is from here. So 1 mole. For this 1 mole. So 2 mole of HIO4 is required to break this compound. What is it? CH2H, CHOH, CH2H. It is glycerol. 1, 2, 3 propane triol. Now, oxidative cleavage also takes place when an OH group is adjacent to the carbonyl group. It can be aldehyde or it can be a ketone. Right? So, see here CHOH, CHOH and CH2H. This is aldehyde group and these two are 2 degree alcohol and 1 degree alcohol. So, CHOH group is also oxidized to formic acid. And this is also oxidized to formic acid. Means as I told you, internal CHOH is converted into formic acid and the CH2H next group is converted into here it is. See, this CH2H is converted into formaldehyde. Okay, so here we are getting 2 molar equivalents of formic acid and 1 molar equivalent of this methanol formaldehyde. Now we'll go for this dihydroxy ketone also. Can be, oxidative cleavage will occur over here. Dihydroxy ketones means CH3, CO, CH3 is acetone. So here 1 H is replaced by 2 OH. So there is cleavage between this and this. See, carbonyl group are here in between these two CH2H group. So 1 mole and 2 mole of HIO4. HIO4. How many moles are required? Here 2 moles because I have where E are here 2 cleavage occurs here. So we'll get 3 compounds: formaldehyde, carbon dioxide, and again formaldehyde. So what does it mean? 2 molar equivalent of formaldehyde and 1 molar equivalent of CO2 is obtained. Clear? So ratio of sometimes they ask ratio. So ratio will be SCHO 2:1 and carbon dioxide. Now periodic acid, that is HIO4, does not cleave compounds in which hydroxyl group is adjacent to an ether or acetal function. For example, here I have shown you. See, CH2O, CH3, CHOH and CH2, CH3. So there will be no cleavage. So no reaction will occur. Here in this case, see, if there is one CH2 group is in between the CH2H and CH2H, means it is not contiguous. So what does it mean? There will be no reaction with HIO4. Is that clear? I will again explain this. This is dihydroxy acetone. So cleavage between these three groups as CH2H, CO and CH2H group occurs. 2 moles of HIO4 is required. This is converted into formic acid. These two converted into methanol. So 2 moles, I am saying 2 mole. 2 moles of formaldehyde and 1 mole of this carbon dioxide is obtained. Clear? Now we'll go for the examples. See here, glycerol, I have explained you. If HIO4, find out how many moles of HIO4 would be required to for the oxidative cleavage, or you can say oxidation of glycerol and by HIO4. So at that time you have to write down the structure first. You should know that it is propane 1,2,3 triol. So this is 1 degree alcohol, 2 degree alcohol grouping and 3 degree alcohol grouping. So first and last, these two will form SCHO. How I am writing this, I will explain you that also. And the middle one, it will give you SCOOH, that is formic acid. Clear? So first of all, you have to write down this grouping. CH2H. See, I am marking it like this. CH2H grouping. And only thing, this bond is alone, so you have to write down OH from here, from HIO4. So water will be lost and you will get formaldehyde. Since there are 2 CH2H grouping, that is why I have written twice of SCHO. So 2 moles of CH2OH, we will get 2 moles of SCHO. Clear? Now if there is only CHOH grouping, see, only CHOH, middle one, CHOH grouping. So I have used 2 OH group, one here and one here. This OH group and this OH group from HIO4. So since 2 OH group cannot be reside for a long period of time, water will be lost over here and you will get SCOH double bond OH over here. That is called formic acid. Is that clear? If one CHOH group is there, HC double bond SCO सिर्फ SCO HCOH है ना, this is OH, so CHOH group is there. So these two are alone. So what you have to do, you have to put extra OH here by yourself, OH and OH. You see what I did? CHOH, I put 2 OH over here, then water will be lost here. I am making 8, so you will get this SCOH. HC, that will be SCOH as it is double bond O, because it is lost, so this bond will come over here. Clear? So now second example. See, you write down this structure first. How many moles of periodic acid would be consumed in this given reaction? This is no need to mark the formula of this. You write down simply the structure: CH2OH, CHOH, CHOH, HOH, HOH, and CH2OH. How many CHOH is here? 1, 2, 3, 4. Understood? 4 moles of CHOH there, so we will get 4 moles of SCOH. I have discussed this. Okay, 4 moles of CHOH, so we will get 4 moles of SCOH. And how many moles of CH2 is there? 1 and 2. So 2 moles of formaldehyde. So easily you understood that 4 moles of SCOH and 2 moles of SCHO is 4 moles of formic acid. This is formic acid. And this is formaldehyde. I think this point is clear to you. And I have explained you this again, but I don't think that it is required now. CH2H, you have to write on, only you have to add 1 OH, and then water will be lost, so you will get CH2O, that is SCHO. And then if it is CHOH, so you have to add 2 moles of OH, and water will be lost here, formic acid. Clear? So these are 2 examples. Now we will discuss more examples. See here. You first of all you draw all these structure so that it will be very easy for you to understand every example. See, CH2O, how many moles of HIO4 would be consumed in this case? So here, see, this is ester group is here, so it will be not cleaved by here, so cleavage between only this and this will occur. So you can only write down the cleavage of this, because it is ester group, it will be, there will be no cleavage. So only 1 mole of HIO4 is required, and you'll get SCHO, and the rest will be same. Here this CHOH is, group is converted into CHO, because the second part is having CH2O CH3. Okay, so if we'll add 2OH, so it will be cancelled out and water will be lost, and you will get this compound. Clear? You can do practice this, it is very easy. Now see here, CH2OH, CHOOCr and CH2H. Is there any cleavage occur? No, not at all, because this ester group is in between. Right, so between these two CH2H, one ester group is there, so there will be no product, no cleavage between this occur. Now, if I am giving you this ethylene glycol, find out how many moles of HIO4 would be required. Just make a wavy line over here, 1 mole, and CH2H, I told you earlier, so many times you had done that it will give you formaldehyde. Clear? CH2H converted into formaldehyde. Now we'll do this. See, this is carbohydrate, means oxidative cleavage of carbohydrates using HIO4 we are doing now. So you have to draw the structure first. How many moles of molar equivalent of HIO4 would be required, and find out the product. See, this whole group, here no cleavage between CHOH, because this and this are in a cycle. So there will be no cleavage between this. So only cleavage where it will occur. So you have to see where it will occur. See, this, there will be no cleavage here, there will be no cleavage over here, because these two are joined to this. So from here, this is cyclic. Okay, so there will be no cleavage, but this CHO and CHO, I am making box. So this is cleaved, this is cleaved, but after that there will be no cleavage. After here, there will be no cleavage. So how many moles of CHOH is required? 1, and this is 2. So 2 mole of HIO4 is required. So now this is CHOH. So again this is, because there is another group over here, that is why it is having only HCCHO, that is aldehyde group. It is not separate. You know, earlier we are doing CHOH separately, that is completely different from this. Here I will explain in separate phase. Okay, so it will be CHO, here again CHO. So here, this is exceptional case. Earlier we are doing here, let me see, till you draw here, I will show you here. 1 mole of CHOH, CH2H, I have explained you here. See, in this case CHOH, OHOH I was putting, and we are getting SCOH. Why it is so that I am not doing like this? Because here in this case CHOH, there is it is adjacent to an other group. See here, I am trying to do like here HCOCH3 CHOH. Now you have to add only OH. Okay, now you have to add only OH, so this water will be lost, so you will get CHO. Now is that clear to you? Because here it is not free CHOH, because it is linked with this. So we have to make the whole group with CHOH. So only OH group will be there. And in ethylene glycol there is free CHOH. See, there is free CHOH. That is why I added 2 OH group here, 1 OH here and 1 OH here. I think this is clear to you. Here it is free CHOH, above CHOH and below CHOH. But here in this case, CHOH is joined with SCOCH3. So you find out this very easily, that it is converted into CHO, this is converted into CHO. See, and the rest of the other thing, cycle will remain as such. Only break, collaboration with this and this. There is no bonding in between this and this. They are separated now. Clear? So 2 moles of HIO4 would be consumed. 1 mole for this and 1 mole for this. So whenever I am making wavy line, it means that much HIO4 must be consumed in these cases. Now, we'll do next one. You have to draw this your own. First you draw, then I'll explain you. Okay. Here see, again the same case here. CHOH and HCOCH3 is there. So cleavage between CHOH and CHOH will be occur. So I am making wavy line here. See, this is wavy line, and then there will be no cleavage. Now here at the bottom there is wavy line, and there is no wavy line over anywhere. So 1 and 2, two wavy lines are there, means 2 HIO4, 2 moles, 2 molar equivalents of HIO4 we can use. Further, there is no need to worry. Sometimes they are saying 2 equivalents of HIO4, the same thing. So see this, we will get CHO group here and CHO group here. For this and for this, 2 different CHO group I am doing like this. Clear? See, CHOH, it is converted into CHO. This CHOH, this is converted into CHO. I think this point is clear. And this bottom one, I am making cloud of it. It is forming methanol. Clear? So we are, what we are getting? This cyclic structure and 1 mole of methanol. So how many moles of HIO4 is consumed? 2 moles. So 2 moles of 1 and 2 cleavage. So 2 moles of this. 2 moles of HIO4 consumed. And itself it is, reduced to HIO3. HIO4 is converted into HIO3. Clear? Now draw this structure. See, HCO, CH3, CHOH. यहाँ कार्बन HOH, मतलब 2 degree alcohol, CHOH 2 degree, 2 degree alcohol, 2 degree. So how many? 1, 2, 3, 4 are there, and then CH2 is joined with this carbonyl group with O. Right? Now this is cyclic, there will be no change. This is, so there will be no cleavage here, no cleavage. But in this, between this CHOH and this, there will be cleavage, there will be cleavage, there will be cleavage. Okay, so how many? 1, 2, 3. 3 moles of HIO4 we are have consumed, and here again I am making circle for this CHO and CHO. And separately, which is the middle one? Where is the middle one? I am making it in a box. Okay, so just wait, here it is gone. This one, this is called middle one. This is middle one and this is middle one. So 2 moles of 2 moles of formic acid is obtained. I am putting green color or blue color to it. This CHOH separate and this CHOH separate. Okay, therefore this 2 moles of SCOH is obtained. Oh, see, 2 moles of CHOH, 1 and 2 mole of CHOH and 2 moles of SCOH is obtained. I think this is clear to you. Again I am repeating it. Draw this structure and you see 1, 2, 3, 4 CHOH groups are there. So cleavage between this, cleavage between this, cleavage between this. In between this, there are 4 CHOH group is there, but 2 are having free CHOH grouping, so they will convert it into formic acid. And above and below, the CHOH group is joined with CH2 and the cyclic structure, so only they converted into CHO. See, I am making it here. This. So topper and bottom, their CHOH group is converted into CHO. And rest you have to draw the same. Draw this structure. I think when you will practice your own, then you will find it very easy to mug it up. Need not to mugging, only see how we are doing this. See, HCO, CH3, draw this structure first. CHOH, CH. Up see here, only see here 1, 2, 3, third carbon. There is cycle. This is acetal form is there. CHOH, CHOH, CH2H. Now cleavage between this and this will occur, and then rest there will be no cleavage. See, I had done this. HCO, CH3, CHOH, CH, CHOH, 1 and 1, 2 and this 1 cleavage and 2 cleavage. After that there will be no cleavage. Okay. Since CHOH does not cleave in the ring, it is located. It will not be oxidized. Clear? Because above is acetal and there is CH in between CHOH group. So only 2 moles of HIO4 is required to oxidative cleavage of this compound. Oxidative, I am writing here. Thank you. You practice it, okay? Because one question always asked in the examination. Thank